Hello everyone, welcome back to my channel. So this is the sixth video of the chapter Matrices, and in this video we'll be learning about the steps to find the inverse of a matrix by elementary operations. So if you don't know how to apply the elementary operations, then you can check out my previous video. I will give the link of the whole playlist in the description box. So let's start. Okay, so now we're going to find the inverse of a matrix. So we knew that there were three elementary operations, and those three elementary operations we can apply it on the row, and the same elementary operations can be applied on the column also. So you can either apply those operations on row or on column, that depends upon you, or they might give you in the question also whether you have to apply the row operation or the column operation. So basically how you're going to find the inverse is, now suppose if we are applying the elementary row operation to find the inverse. Now if they have given us a question and they have asked us to find the inverse by using elementary row operation, then we are going to apply only the row operation throughout the whole process. So what will be our first step? Our first step is that we are going to write this statement that a matrix A, that is the given matrix, whatever the matrix they give us, and they've asked us to find the inverse, that will be a matrix A. Okay, so that matrix A will be equal to the identity matrix of the same order into the same matrix A. Okay, now we are going to apply the elementary row operation on this statement. So basically what we have to see here is that the row operations, whatever row operations we are going to apply, we will apply it on the matrix A of LHS and on the identity matrix of RHS. Okay, so we have got different elementary operations, right? Like we can interchange two rows, like this we can interchange rows, row 1 and row 2, or maybe we can add a row, like row 1 can be changed to row 1 plus row 2. So these are kind of elementary operations. So whenever we perform an elementary operation, we are going to perform that same elementary operation simultaneously on both this matrix A of LHS and the identity matrix of RHS. Okay, so you can see the statement over here also. So when we apply that elementary operations on the matrix A of LHS and on the identity matrix of RHS, and the identity matrix also should be of the same order as that of the matrix A. Okay, so when we apply this the matrix A, like we have to keep on applying the elementary operation till the LHS matrix A gets converted to an identity matrix. Okay, so you have to keep on applying the elementary operations till we get an identity matrix on the left hand side, and while we are applying the elementary operations, we are applying that on this identity matrix also. So when we keep on applying that identity matrix, at last we will get some matrix B, and that B will be the inverse of A. Okay, so basically what we have to do is, in case of elementary row operation, our first step is to write the statement that is A is equal to IA, where A is the given matrix and I is the identity matrix of the same order. Then in case of elementary row operation, we have to apply that operation on the A of LHS and the identity matrix of RHS. And now we have to keep on applying this different elementary row operations till we get an identity matrix on the LHS. And as soon as we get an identity matrix on the LHS, whatever the matrix B is there along with this matrix A. Now this matrix A which we took in the starting, this has to be this we have to leave as it is. Okay, no changes should be made. The changes are only made on this LHS and RHS of identity matrix. So this matrix A of RHS has to be left like that. We don't have to make any changes. So now at last when we get a different matrix P, that P will be the inverse of A. So that is how we find the inverse using elementary row operation. So if you want, you can find the inverse using elementary column operation also. Like you can see here, in case of elementary column operation, this is the statement that you have to write. So basically in case of elementary row operation, you were writing A is equal to IA, and you were applying the row operations on this A and this I. But in case of column operation, what you're doing is you're going to write A is equal to AI. Okay, you're going to write the identity matrix afterwards, and then you're going to apply the column operations only on this A of LHS and this I of RHS. Okay, so you always apply the operations on the matrix A of LHS and on the identity matrix of RHS. The only difference in both of them is that the arrangement of I. That is, in case of row operation, I will be first, and then in case of column operation, I will be the second matrix coming. Okay. So that is what we have done here. So we will apply the elementary column operation on this A and on this I. And when we apply this, as you can see, this A of LHS and I of RHS. So we have to keep on applying this elementary column operations till we get an identity matrix on the LHS similar to that row operation one only. So till we get an identity matrix on LHS, we have to keep on applying that column operation, and the same column operation has to be applied on both of this LHS and RHS. Okay, and RHS only, it has to be applied only on this identity matrix, not on this matrix A. Okay, this has to be left as it is. Okay, so when we keep on applying and when we get an identity matrix I on LHS, then whatever the matrix B we get along with this A, which was left as it is, that matrix B becomes our A inverse. Okay, so that is how we find the inverse of a matrix, by using the elementary operations. So you can either use row operation or you can use column operation. Anyone you can use, you will get the same answer in the ending. Okay, so now let us solve some questions along with examples. Now before we move on to the questions, one important note over here is while we are applying these elementary row operations, if all the elements of a particular row or if all the elements of a particular column becomes 0, then we can say that the inverse of that particular matrix does not exist. Suppose we keep on applying the elementary row operations or elementary column operation, and we get something like this 4 5 0 0. So you can see here all the elements of row 1 have become 0, which means that we can stop the process over there and we can say that the inverse does not exist. So this is one of the important points. Now let us solve some questions. So this is one of the previous year question, and in this question they have asked us to use the elementary column operation. They have also given us the elementary column operation, this one, and they have asked us to apply it in the matrix equation. So we know about this one, that in case of column operation, we write A is equal to AI, okay, basically, and then what we do is that we apply this column operations on the LHS matrix A, okay, left hand side matrix A, and then we apply the same column operations simultaneously on the second matrix of the RHS side. Okay, so in this case there is no identity matrix, so what we are going to say is we are going to apply the column operation on the LHS matrix and on the second matrix of the RHS side, that is right hand side. Okay, which means that we are going to apply the column operations on this matrix, that is the LHS matrix, and the second matrix, that is this one, and we are going to apply this column operation simultaneously and we are going to find the answer. Okay, and this second matrix, this first matrix will remain the same as it is. Okay, so now let us solve this. Okay, so now we have to apply this column operation. Now what does that column operation says? It says that the column 2 will be changed to column 2 elements minus 2 times of column 1. Okay, so this was one of our elementary operations, if you remember, which I've explained in the previous videos also. So what I'm going to do here is, this is my column 2. Okay, so the elementary column operations will be applied on this matrix and on the second matrix. So here this is my column 2. Okay, so basically I am applying the operations on the second column only, and it will be interchanged in such a way that I am going to subtract this like column 2 elements minus 2 times of column 1 elements. So this will become, the first column will remain as it is, and the second column will become column 2 element, that is 2, minus 2 times of corresponding column 1 element. Okay, look, just pay attention to this matrix, this elementary operation, and the same you have to apply over here. So basically what I'm doing is I'm writing the column 2 element, that is 2, minus 2 times of corresponding column 1 element, which is nothing but 4. Okay, and then for the second one also I'm going to write the column 2 element, that is 3, minus 2 times of the corresponding column 1 element, which is 3. Okay, so that is how I've applied the column operation on the LHS side. Now the same column operation I have to apply on the RHS also, but this matrix will remain as it is, this one, since it is a column operation. In case of row operation, the second matrix will remain as it is. Okay, so this is a column operation, so this first matrix of RHS will remain as it is. That one we know. Now we are going to apply it on this one. So the first column will remain as it is, and the second column will interchange in such a way that I'm going to write column 2 elements minus 2 times of corresponding column 1 element, that is 2. Okay, now for the second one also, column 1 element, that is 1, minus 2 times of corresponding column column 2 element, that is 1, minus 2 times of corresponding column 1 element, which is also 1. So when I solve this, what I get is 4, 3, minus 6 and minus 3. Okay, basically I'm just solving it. Now this matrix will remain as it is. There was no change on that. We did not apply any kind of operation on that because we are right now applying column operations. So we have to leave that matrix as it is. And this one will become minus 4 and minus 1. So this is our required answer. This is what we wanted. After applying the elementary column operations, we got our equation. So this is our final answer. So that is how you apply your elementary column operation. Now let us see one more question related to this. So in this question they have asked us to use the elementary row operations, or you even call it as transformations, and they have asked us to use that, and we have to find the inverse of this matrix A. Okay, so this is what we have to do. Now in this question they have specified us that we have to use this elementary row operation. Even if they don't give us, you can either use elementary row operation or elementary column operation. By using any one of them you'll get the answer. So since in this they have asked us to use the elementary row operation, we know that in case of an elementary row operation, we first write the statement that A is equal to IA. Okay, so here our given matrix should be A, and they have given us the matrix A. So we are going to write that matrix A, that is A is equal to IA. I is the identity matrix of the same order. That is, right now here this is of order 2 by 2, or you can even say of order 2 since it is a square matrix. And we are going to write an identity matrix of same order 2 by 2, and then we are going to apply these elementary row operations till the left hand side matrix A turns into an identity matrix, and in the right hand side then we'll get us some other matrix which will be our inverse. Okay, so like this we'll get our A inverse. So that is how we apply our elementary row operation. Now let us see what to do. So here in this case also we'll first write A is equal to IA. Okay, since we are applying elementary row operations. Okay, now what we are going to do is first we will write it like that: 1, 2, minus 1 and 3. This is our matrix A. Then we have to make one identity matrix of the same order. Okay, and then we will write A as it is. Now I'm writing that A as it is because we are not going to make any changes on that A. All the operations are going to be performed on this A, this left hand side matrix and the identity matrix, and that right hand side and that last A will remain as it is. There will be no changes. That is why I'm just writing one A. Okay, so now I'm going to apply the row operations only on these two matrices, and we will get a final answer. So I have to apply the operations in such a way that I get an identity matrix on the left hand side. That is, this matrix should be converted to this form: 1 1 1 0 0 1. Okay, so I have to get it in such a way that this matrix becomes this identity matrix. Okay, so in that case what row operations do I have to perform? Now when I see, basically what I'm going to do is, my first step will be if I check if this first one element is 1 or not. So that is 1. Now the next element should be 0, and this should be 0, and this should be 1. Only then it will turn into an identity matrix. So if I see here, if I apply this row operation, that is row 2 will change into row 2 minus 2 times of row 1. So I have made this transformation and applied this transformation so that I get a 0 in place of this 2. Okay, so you have to make your own transformations. You have to check this by trial and error method. You have to make it on your own, and then you have to find the answer. So when I apply this elementary transformation, what I get is my row 2 will be changed to row 2 minus 2 times of row 1. So this is my row 2. Okay, so we are basically focusing on the LHS side, but we don't have to forget that on the RHS also we have to perform the same elementary transformations. Okay, that is basically the rule. So what I'm going to do here is the row 1 elements will remain as it is. Now the row 2 will become the row 2 element minus 2 times of row 1. Corresponding row 1 element here is 1. Okay, then in place of 3 we are going to write 3 and minus 2 times of corresponding row 1 element, that is 1, minus 1. Okay, and then over here the same elementary operations we have to perform here also. So the first row will remain as it is, then the second row will become row 2 minus 2 times of the corresponding row 1 element, that is 1. Here also row 2 element was 1 minus 2 times of corresponding row 1 element, which is 0, and then that A will remain as it is. So when I solve this, what I get is 1, then here I'll get a 0, that is what my aim was, and then this will become minus 1, this will become 5. Okay, so this is what I've got after applying this row operations. Okay, so this is what I got. Now this after this I have to apply another row operation. So this is what I had got after applying the first row operation. Now I have to again check the LHS, and I have to check now what step should I do in order to convert it into identity matrix. So my identity matrix is something like this, right? So I got my row 1, that is 1 0, the same row 1 I got. I just have to column 1, and then I just have to apply different row operations in order to get this column 2 also. That is, I should get this 0 in place of this minus 1 and 1 in place of this 5. Okay, so now let me do this next step, that is I'll convert this 5 in such a way that it will become 1. So if I want to do that, I have a very simple row operation, that is I can do row 2 will turn into 1 by 5 times of row 2. That is, this is my second row, and I'm just going to multiply all the elements of that second row with 1 by 5. Okay, basically I'm dividing that with 5. So when I divide 5 with 5, I'll get 1 as my answer. So the same row operation I'm going to apply on RHS also. Okay, so don't forget the step that you have to apply the same row operations on RHS side also. So when I do that, I get 1 minus 1, that is the first row will remain as it is. The second row will become 0 divided by 5. Okay, so 0 divided by 5 is 0 only. So let me write it as 0. Now this will become 5 divided by 5. Okay, so 5 divided by 5 is 1. So this aim is also fulfilled, that I got a 1 over there. And the same operation I'm going to apply over here. This will be 1 0. Now this will become minus 2 by 5, and this will become 1 by 5. And this A will remain as it is. Okay, so I did this. Now my last aim is just to convert this minus 1 to 0, and then I will get my identity matrix. So now I have to search for such kind of a row operation in which if I do something, that minus 1 should become a 0. Okay, so I can see that I have got one row operation where I can convert the row 1 elements in such a way that I can add row 1 plus row 2, because if I do that here, this row 1 and row 2 element, if they add, they will only lead to 1 over here in the first column, and in case of this one, it will become 0. So that is how you have to just check. You have to do this trial and error method, and you have to find your own operations. So if I do this, if I apply this operations, I'm going to get a 0 over there. So basically this will be applied on the first row only. So this here is my row 1 and this is my row 1. Okay, on both the sides you have to apply. So when I apply that, my row 2 will remain as it is, that is 0 and 1, and the operation is on row 1. So this becomes 1 plus the corresponding row 2 element, that is 0. So 1 plus 0 is 1. and on the other side this becomes minus 1 plus 1, because the corresponding row 2 element was 1. Okay, what we are doing is we are in case of the row 1, we are basically writing the row 1 plus row 2 elements. Okay, so here row 1 element was minus 1 and the corresponding row 2 element was plus 1. So when I add both of them, minus 1 plus 1, I get a 0. Okay, so finally I got an identity matrix on my LHS side. Now I'll apply the same elementary operation on my RHS also, and this becomes minus 1 plus of minus 2 by 5. Okay, I'm going to add the row 1 element with the corresponding row 2 element. Okay, the same thing I'm going to do with this one also, 0 plus 1 by 5. Okay, which is nothing but 1 by 5 only. Now this will remain as it is, and this will also remain as it is, and here you'll get an A. Okay, that's the same matrix. So finally I got an identity matrix on my LHS side. Now I just have to solve this thing. So when I solved that previous equation, that is when I solved this one, I got this. So basically my aim was to get an identity matrix on the LHS side, which I got over here. So I can write this, that the identity matrix is equal to this matrix 3 by 5 minus 2 by 5 1 by 5 1 by 5. Okay, so I got an identity matrix on my left hand side. Now if you remember, the RHS matrix I have to check, that is I have to check this matrix, and this matrix will become my A inverse. Okay, if you remember the step, I'll just revise once again. I did this, I wrote this first step because I was using elementary row operations. I wrote I first, then I applied those row operations on this A and on this I until my left hand side became an identity matrix, and this identity matrix turned into some other matrix B, and this A matrix remained as it is. Now this B has now become my A inverse. Okay, this B is now my inverse of A. That is my final answer I got. Now I had to find the inverse of matrix A. That is what I got. So I can say that this is the A inverse. You can write A inverse or you can write B, and this is my final answer, that the inverse of my matrix is this. Now so as soon as you get the answer, if you want to cross check your answer, you have got one method that if you want to cross check, you can apply this. When you multiply your A inverse with your matrix A, you should get an identity matrix of the same order. This is what you should get. So in case of this one also, if you multiply this A inverse with the given matrix A, which was given in the question, and if you get the answer as an identity matrix, which means that this A inverse is the correct inverse, that is your answer is correct. So this is a way to cross check your answer, that is you can do A inverse minus A, which is equal to identity matrix. In this question you did not show that, but you can cross check it by using this method. So that's all for this video. Now with this video we have completed our matrices chapter. So in this we learned how to find the inverse of a matrix by using the elementary operations. So if you still have any doubt, you can let me know in the comment section below. Now thank you for watching, and meet you in my next video.